Hello students, this is a video guide to the problem sets from lessons 5 through 8 from Unit 10. We're talking about circles in Unit 10. This is a little preview of what you're going to see. We're going to be talking about equations of circles. We're going to be looking at sectors of circles, which are little wedges of the circles. We're going to be looking at the arc lengths and the area. If you didn't already try the problem sets, please pause the video, try the problem sets, well, specifically here, lesson 5, and then unpause the video, see if you did it right. All right, for this particular problem set, you did need a compass. If you didn't have a compass, I'm sure they sell them at the dollar store, but the compass was very useful in order to do these problems. For example, for the first problem, we made a 4-point framework. We drew a diameter, and then we drew the perpendicular bisector of that diameter. Once we did that, we had 4 points that were evenly spaced around the circle in order to construct a square. And it asked why the measure of the arc intercepted by two adjacent sides was going to be 180 degrees. Well, it's because these two adjacent sides here have a 90-degree angle. And it's an inscribed angle, which means the intercepted arc is twice that. So 90 times 2 is 180. Next, we made a 6-point framework. We measured the distance of the radius using our compass, and then we made those arcs around the circle, which made not a 4-point framework. We call this a 6-point framework. In order to make an equilateral triangle, we connect 3 of those points that were non-adjacent to each other, and then we got our equilateral triangle. It asks again what an intercepted arc would be. This angle is equal to 60 degrees. It's an equilateral triangle, which means 60 degrees each angle, and that means the intercepted arc is going to be twice that. That's 120. The next page is another constructions page. Pause the video and see if you can get these right. Okay, for this one, it asks us to make a line tangent to circle O. The only thing I know about tangents and radii is that they intersect at a right angle, which means I need a construction that gives me a right angle. Why not perpendicular bisector? Perpendicular bisectors make perpendicular lines, which have right angles. So I copied the radius out here, and then I made a perpendicular bisector of my new line. For number 4, there are a number of different ways to do this, to copy a triangle. I think the easiest way to do it is to do the Sss Postulate, which means we're going to copy one side, and then from that side, we're going to copy the lengths of each of the other sides. So you can see that I did that in green and red respectively. And then once I'm done with that, I find the point of intersection and I connect the dots. This point is going to be exactly the correct distance away from point A because it's the same as the distance from Z to X. And this point is also the same distance away between C and B as between Z and Y. For number 5, it asked us to do a lot of stuff. This is not a Regions type question. This is a challenge question. First, make an inscribed circle, a circle that's inscribed in equilateral triangle. In order to do that, you have to remember your triangle centers. ABI stands for angle bisectors in center, and the in center is for an inscribed circle. If you remembered all that, you made that inscribed circle by finding angle bisectors, and then you took that circle and you drew a square inside of it using that same 4-point framework that we did in question 1 of this lesson. All right, moving on to question number 6, or lesson number 6, I should say. Pause the video and see if you can get these right. All right, in each of these questions, it asks us to find the equation of a circle or use the equation of a circle based on 2 things, the center and also the radius. In this case, the radius was 5, the center was 0, 0. And remember, the equation has the radius squared, so whatever that radius is, we're going to square it to make the equation. Same thing here. We know the radius is 6, so that last number is supposed to be 36. The equation has the center, the 0, 4, for example, but the signs are switched. So if the center is 0, 4, the equation is going to have a negative 4 in it somewhere. That's next to the y value. So negative 4 next to the y value is right there. The center here is negative 5, 1, and the radius is 3, so we were able to do 5, negative 1 in our parentheses, so 5, negative 1 in parentheses, and they're going to try to trick you. You find the radius, which is equal to 3, but you know that in the equation, that's got to be 3 squared, which is 9, so the answer is choice B. This one was a little weird because you couldn't find the exact radius. We don't know, 3.5, 3.6, whatever it is, but we know that whatever that number is, we're going to square it to see what's in our equation. And 3.6 squared is 12.96. Well, I don't know who you are or where you're from, but I know that 12.96 is pretty close to 13. So we don't know the exact radius, but we estimated it and we got pretty close. And we also know that the center is -3, 1, which means 3, -1, or 3 and -1 rather, are in the equation. Same idea here, except we need to find the radius, and we're given these 2 exact points. So if we get 2 exact points, we can find the radius very easily using the distance formula. So the distance formula gave us radical 13, and again, in our equation, we're using 13 because this number is the radius squared. So radical 13 squared is just 13. And then 5, -2, because this is -5 too. The endpoints of a diameter, so we're going to find the distance formula for the diameter, so that's 10. The radius must be 5. And then it gives us the diameter, which is the 2 endpoints of a diameter specifically. And then in order to find the center, we're going to use, this looks like it got cut off by the video, we're going to use the midpoint formula because a diameter's midpoint is always the center of a circle. So here's the midpoint formula. We got 8, 13, which means -8, -13 in our equation. This is the second page of the problem set. Take a look at this, see if you can make any sense of it, and then pause the video and see if you got it right. All right, in this case, we got h is equal to 2 and k is equal to -2. Remember, h and k are the values of the center of the circle. H is going to be the x value, and k is going to be the y value. It says the values of h and k are doubled, so I multiplied them both by 2, and it didn't say anything about the radius being doubled, so C is not the correct answer. I know it's got to be D because my h is going to be 4, 2 times 2 is 4, and k, which is -2 times 2 is -4, so it's down here. All right, the first part of this question asks us to figure out what point is located on circle W. I found the radius of 5 because this point and this point are 5 units away from each other. Don't believe me? The 2, the y value, is the same exact value, and the 1 and the -4 are 5 units away. So they're 2 points that are horizontal from each other. Graph it if you don't believe me still. I know the radius is 5, which means in the equation it's 25. The center is -4, 2, so 4 and -2 go in my equation. And if I want to find a point that's located on circle W, I got to take these points and substitute them into my equation to see which one gives me 25. And it's only letter C. I didn't show you the other substitutions because that's too much work. For question number 9, it asks us to write the equation of a circle. And then if you remember in class, we tried to determine whether a point is on a circle, inside the circle, or outside the circle. We just talked about if the two numbers are equal, it tells us that it is on the circle. If this number is smaller than the radius squared, that means it's inside the circle. And if this number were to be 100 or 1,000 or 1,000,000,000, then that number is bigger than the radius squared, which means it's outside the circle. These questions were very straightforward. Give the radius, the diameter, or the equation, and then try to figure out the area and circumference using the area and circumference formulas. Remember, cherry pie is delicious. Apple pies are too. I always have a fun time saying that. Let's see. The one thing I wanted you to point out here is that this 12.6 and this 12.6 are the same number, but they mean different things. Remember, square units is space inside a shape. It's the area that's inside of a shape, whereas units is just the length. It's the distance around a shape. That's the difference between these two measures. Moving right along to lesson number 7. This is the problem set, so pause the video, try these questions, and see if you got them right. Turns out that Amy and Dex are both wrong, Beth and Carl are both right, and we're using this area equals theta over 360 times pi r squared formula. This is the area of a sector, a part, a wedge of the circle. All right, for this question, it's asking for the area of the shaded region. This case, it's given to us that the angle is 60 here, but we want the shaded region, so the angle of the shaded region is going to be 300. We plugged it into the formula. That's the same exact sector formula. And in this case, it says in terms of pi. So in terms of pi means I want pi in my answer, which means don't put pi into your calculator, because if you put pi into your calculator, it's going to give you a weird, crazy decimal. You're going to do all the other numbers. For example, here we did 5 divided by 6 times 64, and then pressed math, enter, enter to get a fraction. So that's 160 over 3. And remember, the pi goes in the top of the fraction because you're multiplying, you're not dividing by pi. So 160 pi over 3. Same type of question here. We have a area of the shaded region question, which it's the same exact angle as before. Interesting. In this case, though, it's asking for the nearest square foot. So if it says the nearest blank, you do put pi into the calculator and then round to whatever it says. Here it says the nearest square foot, so we round it to the nearest unit. That's 589. And remember, feet squared has to be there because we're looking for an answer in terms of square feet, so we need the units. Here's the next page of this problem set. Pause the video and see if you can get these right. We're still using this area equals theta over 360 times pi r squared formula. This is the area of a sector. It was the same area as the beginning of the video. All right, it gives us the radius is 15 centimeters. The 75 pi centimeters, that's going to be the area. So what we're doing is we're substituting an area, and then we're sort of back solving to try to get that theta, which is our variable. Notice from here to here, the pi's disappeared. There's no more pi here. There's no more pi here. When there's pi on both sides of the equation, just like when there's any number on both sides of the equation, we can divide the equation by that, and it disappears, or it gets eliminated. Then I did a cross multiply in order to get the angle, and that angle is 120. This is just a very easy algebra review. For number 5, it was a similar situation. It gave us the area, and we had to back solve in order to find that theta. We're going to do the familiar pi disappearing trick. Delicious. And then we're going to do a cross multiply in order to get 7.2. Same thing here. We're given the area, and we're given enough information to get us to where we need to go. That theta is going to be equal to 80. And in this case, we're given the unshaded area, which is 500 pi. So I found the angle for the unshaded region, which is 288. And then I knew that 288 degrees is only part of the circle. 360 minus 288 is going to be 72. So this angle Q is 72 degrees. Here's a little preview of the next lesson. Arc length is the distance around the circle for one sector. So we used this new formula, which is, you should recognize, circumference equals pi times diameter. But if we're looking for part of the circle, we do this part of the circle, which is part of the sector formula as well. So 72 over 360 is our part of a circle, and long story short, we get 10 pi. All right, last problem set. Pause the video, see if you can get it right. All right, here we were talking a lot about the arc length, and this is the arc length formula, as you remember from the beginning of the video. Most of these is simply substituting into this formula and figuring it out. Keep in mind, radius is 5 feet. That means we're plugging in 10 or substituting 10. The radius is 7 feet. That means we're substituting 14, because every single time we're supposed to be substituting the diameter. More substitutions here. This one was a little bit different because it gave us radians, so we had to first convert radians into degrees. We did this in class. Anytime you get radians, we multiply by 180 over pi in order to turn it into degrees. In this case, it didn't give us the central angle, but we were able to figure it out because the circular pizza has 8 equal slices. 360 is the whole pizza, divided by 8 is 45 degrees. Ooh, pizza. And then for this question, it gave us enough information to figure out the length of arc AB by taking that 120 and substituting into our formula. It wasn't that dissimilar from the previous questions. Last page of the last problem set. Pause the video, see if you can get them right. All right. In this first case, we were again given radians. This is an angle in terms of radians. And luckily, this is a very easy conversion. We're just multiplying pi over 3 times 180 over pi. The pi's eliminate, so 180 divided by 3 is 60. And then we substitute into the formula and got 4.2. It says round to the nearest tenth, so that's what we did. Next question, very straightforward, substitute into the formula. This question, it was given to us that the circumference is 116 pi, so we back solved from c equals pi times diameter to get 116 for the diameter. Radius is half that, and then the circumference of part of the circle is going to be that same exact circumference formula, that arc length formula. And then last but not least, it asked us whether Dominic was right in the fact that these angles were 45 degrees. There was a little bit of solving that needed to be done, but it's just algebra, and all of this algebra gave us the fact that they're both angles of 45 degrees. All right, this video was designed to help with lessons 5 through 8 in Unit 10 for circles. Good luck studying.